please stay healthy and safe. And I hope I will meet you guys soon. Today I will exploring the new topics, so I'm going to record the videos. First thing, do you guys still remember how to distribute these factors? Because this is x plus 1 times x plus 2, right? And usually how we extend this factor, we call distributive properties, or we call Fourier method. I hope you guys still remember this. So this Fourier method, the first term multiply this, and then this multiply this, and then this term multiply this term, and this multiply this. So that's x times x, x times x, and then plus this is x times 2. That will be 2x, and then to this term 1 times x. That is 1x. So this is x, and 1 times 2 will give us 2, right? And then this is x times s, that is x squared, remember. And then this, so we combine the like term, right? This is x, this have 2x plus x. This is like term, both have x. So that means it's 2 plus 1. They give us 3. So 3x, and then this is a constant 2. This is a like term, go to here. So this is how we try the distributive property to extend this trinomial, okay? And then I also want to record what is factoring. I think we learned 2 weeks ago. For example, 36. What are the factors for 36? They have 1 times 36 give us 36, or 2 times 32, 2 times 18, yeah, this is 36. What else? There's 3 times 12, or 4 times 9. Those are the factors. Again, I give an example. X squared plus 7x and plus 12. We try to factor this to write in an factors form. So we mean like we write it as something times something, that as a factor form. And we know apply the distributive property, then we explore the pattern like s plus d or s plus e. We know this, like at the beginning we review how to apply the distributive properties to extend this to a trinomial form, right? So this time this term times this term, and then this time this time this. So x times x is x times s, and then plus s times e, that is ex, and then d times x, so it's dx, and then d times e plus d times e. Remember here the d, e represent for some constant, and x is our variable, okay? So x times s is x squared, and then we combine the like term. You see, this is ex plus dx. They both have x term, so we combine this. That will be e plus d, or we say d plus e times s, and then plus d times e. You see, what you guys can notice, if we given this, how this term, you can think about this as a factor form, right? So you see this term is a product, is a summation, is d plus e, and the constant is d times e. What's that mean? You see, if this is a trinomial term, this is ax squared plus something bx plus c, right? This is a constant, so that means we try to find two number, multiply to get this number, right? So it's d times e, and then two number adding together to get the b term. So then when we relate it to this, so what is the factor for 12? We know 12, the factor can be 1 times 12 is 12, right? Or 2 times 6 give us 12. Or 3 times 4 also is 12. What else? And no more, right? Then we try to find which of those pairs factor adding together will give us 7. Just like here, see, two number multiply get 12. That means that those number, and then those two number adding together to give us 7. What is this 1 plus 12? With this 1 plus 12, this is 13. That's not equal to 7, so that's not. And then this is 2 plus 6. This gives us a. A is not equal to 7, so it's not. And then this is 3 plus 4. This gives us 7. Great. So we're choosing this factor. Then we're choosing this one, right? So then we're going back to write a factor form like this, right? So there I have x here. And this is 3, 4, which means like d here is 3, e here is 4. So s plus 3, s plus 4. Which means if we factor this trinomial, it will give us this. So this is our answer. Okay. Or we can check to see, to apply the distributive property to check if we can get back this trinomial. Okay. Like, okay, this term multiply this term, and first term multiply the last term, and the inner term multiply together, and then this term multiply this. So s times x, x times x, and then plus is s times 4, that is 4x, and then 3 times x, that's 3x, okay. And then 3 times 4, that's 12. Okay, then we combine the like term. X times x, that is x squared. 4x plus 3x, this is a like term. So 4 plus 3, they give us 7x, and then the last term is 12. You see, this is exactly the same as this trinomial form. So that means this is our correct answer. Okay, this is how we factor the trinomial term. This is the strategies, but remember, this method only works when the leading coefficient here, the a term is equal to 1. Okay, there are no other bigger number than 1 in front of the x squared. So when the leading coefficient here is 1, no other constant, then we apply these strategies. We're finding two number multiply to get the constant, to get this number, and then to see which two number adding together will give us the B term, those factors of what we want. Then we can write it. Example. I give you a square plus 13. Oh no, this we say plus 3a plus 2. Okay. Then how can we factor this as a factor form? We're using the strategy that we just learned before. We look at this constant. This is 2. So what are the factors of 2? They can be 1 times 2 give us 2. Anything else? No more. So that we can check. Is 1 plus 2 equal to 3? 1 plus 2 give us 3. That is match our B term. This is exactly 3. So then we write as a factor form. So this is A. This is A. Okay? And we have two numbers, 1 and 2. Plus 1. I have x squared plus 6x plus 9. How can we factor this one? We look at the 9. So what are the factors for 9? 9 is 1 times 9 or 3 times 3. Nothing else, right? So it's 1 plus 9 equal to 6? No. 3 plus 3 is equal to 6? Yes. So then we choose this factor. This is what we want. Okay, so then we write it as a factor form. This x, this x. And we know it's 3 and 3. S plus 3, S plus 3. Okay? And then you can check to see, to apply the distributive property to see if we get exactly the same trinomial terms like this. This time this, this time this. Multiply this number and then multiply the last number. S times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Then we combine the like term. This is x squared. 3x plus 3x is 6x. And then the last number is 9. See, this is exactly the same expression like this. Okay? This is how we apply this strategies or method to write a trinomial expression in a factor form when the repeating number. For example, if we have this x squared minus 10x plus 25. Okay, how can we factor this? Because now this is negative. We can still, because this is really coefficient 1, so we still can apply the same method. We also look at this number. This is constant. This is 25. So what are the factors for 25? 25, let's say it's 5 times 5. This gives us 25, right? Anything else? Or 1 times 25. So 25 can only have either 5 times 5 or 1 times 25, right? But then we think, hey, this is negative 10. You have 5 plus 5 that gives us 10, but not negative 10. Try this. 1 times 25, then we have 1 plus 25. This is not negative 10. Then we need to think, is any other number to multiply to get 25? How about negative 5 times negative 5? If negative 5 times negative 5, here, if I say negative 5 times negative 5, this is still give us 25, right? Because negative, negative, positive. So negative 5 times negative 5, this is 25. Then we think, is it negative 5 plus negative 5? Give us negative 10? Yes. It's negative 5 plus negative 5. This is negative 10. That is exactly our b term here. So now we can write it as a factor form. This is still x, but now because we're choosing is negative 5, negative 5. Those two number is what we want. So that will be a minus 5 and minus 5. Okay, so this will be our answer when we factor this expression. We can check to see if apply the distributive property to see if we get this expression. Okay, so the first term times the inner term, the first term times the last term, this times the inner, negative 5 times negative 5. Okay, and this is negative x times x, x times x. This is x times negative 5. So that will be is negative 5x. Okay, and in this term, negative 5 times x. This is also negative 5 times x. And in the last term, negative 5 times negative 5. Negative 5 times negative 5. So it's negative 5 times negative 5. Okay? So this is x times x. This is x squared. Then we combine the like term. Negative 5x minus negative 5x. So we still have, so negative 5 minus negative 5. This is negative 10. Don't forget the x. And then here, plus negative 5 times negative 5. So negative, negative, positive. So that means it's positive 25. See? This one is exactly the same as this expression. So this factor form is correct answer. Okay? For example, I have x squared minus 16x plus 64. Okay, we apply the same strategy. What are the factors for 64? 64, we have of course 1 times 64. Because 64 is even number, we know they have a factor 2. So it is 2 times 32. Yeah. What else? 4, okay? 4 is no. So 6 that's no. Then it's 3 is no. Then it's 4, 5, 6, 7, 8. Yes, 8. Or 8 times 8. Let's give us 64. Then we check. You see, this also is a negative number. The b term is negative number. So we know we have to using a negative number somewhere here. Eh? Definitely is 1 plus 64 is not negative 6. Is no. 2 plus 32 is not negative 6. 8 plus 8 is positive 6. but we need negative 6. So what we do, we add a negative sign here. It's negative 8 times negative 8 equal to 64. Yes, because negative, negative, positive. So a times a, 64. And we also know negative a plus negative a is negative 16. So negative a plus negative a. This is give us negative 16. This is our b term. So now we can write it as a vector form. This, x and x. Okay? And then we choose a negative a and negative a. So it's negative a and negative a. Okay? This is our vector form. And also we can write one more step because we see these two terms are the same, right? Okay, because s minus a times x minus a. For example, because this means, how about if we say x times x? We know this is give us x squared, right? Because these two terms are the same, then we have the exponents too. The same idea here, because these two terms are the same. So we can write it as s minus a and square. Okay, so we can write it as this format too. Of course, for now you can, because now we are running the factor form, so we can just using this. You can leave this is okay, but furthermore, we can write it as introduce one more problem about x squared minus 7x minus 18. Now we have both a negative number. Okay, we apply the same strategy. Negative 18. What are the two numbers multiplied together give you negative 18? Now we have negative 18 because it's negative. We know that we should have one negative number multiply the other positive number, then we give us a negative number, right? Because positive negative give us negative. Then we can try. We can just look at the negative 18 first, because then we have 1 times 18, or 2 times 9, or 3 times 6. Those are the factors for 18, right? But we want a negative number, and we want when the sum adding together to give us a negative 7. We try this. If I have a negative 1 here, negative 1 plus 18 is give us negative 7? No, because negative 1 plus 18 is a positive 17, right? How about this? Then we can try, is it, if I have a negative sign in front of 2, that will be negative 2. So negative 2 plus 9 is negative 7. Negative 2 plus 9, this is positive 7. But we want negative 7. So how about we switch the sign? We have a negative sign in front of 9. So which means 2 times negative 9. So 2 times negative 9, 2 times negative 9. This is negative 18. And then how about 2 plus negative 9? So that means it's 2 minus 9. What's 2 minus 9? It's negative 7. This is exactly the b term that we have. So now we know we want to choosing this. 1 is 2 and negative 9, right? Because 2 times negative 9 is negative 18, and 2 minus 9 is negative 7, which match our b term and c term. So we can write it as a factor form. This is x, this s. We're choosing 2 and negative 9. So we plus 2, negative 9, minus 9. Okay? So this is the factor for this trinomial expression. Okay, we can check to see if we have the correct factor form. So we'll try the distributive property. X times x, x times x, x times -9, that's -9x, 2 times x, that's 2x, 2 times -9 is -18. Okay. Then we combine the like term. X times x, this is x squared, -9x plus 2x. So we combine the like term. This is x, so that means -9 plus 2. That's -7x. Then we have -18. You see, this expression is exact the same as this one. So which means this is our correct answer. This is the factor form. Okay. Got it? So basically, whenever you see the leading coefficient in front of x squared is 1, we can apply the same strategies. Please be aware to check if the C term here is a positive number or negative number, and then we try to add those two numbers together to get the B term. These are the strategies. Okay. Yeah. Please try to practice more, then you will have the idea how to using this method to factor the trinomial expression. Okay. Thank you.